Hi everyone. In this video we're going to talk about electrostatics, and we're going to look at what an elementary charge is and then do a Regents problem about elementary charges. So the Regents question we're looking at is question 37 from 2014, and it says two identically sized metal spheres on insulating stands are positioned as shown below. The charge on sphere A is negative 4.0 times 10 to the negative 6 coulombs, and the charge on sphere B is negative 8.0 times 10 to the negative 6 coulombs. The two spheres are touched together and then separated. The total number of excess electrons on sphere A after the separation is blank. So of course I'm going to start by annotating, and I'm going to circle the numbers. These are already labeled on my diagram, so that makes it easy to see. I'm underlining the unknown. And here it says the total number of excess electrons on sphere A. So that's what we're looking for. I am only underlining electrons on sphere A. And then I'm going to box the keywords. I put a box around touched together and then separated, because that's a very specific type of problem. And there's actually no equation that we're going to be using necessarily for this. It's more of a concept. So when you have two conducting spheres that touch together and then separate, something specific happens to the electrons. And to get a better look at this, I drew in 4 negative charges on the left on sphere A and 8 on sphere B, and I just did that to match these two numbers, even though it doesn't actually mean that there's 4 electrons and 8 electrons, because negative 4 times 10 to the negative 6 coulombs is totally different than 4 electrons. But it's a good way to just get a visual on what's happening. This one definitely has more electrons compared to this one, but they both have extra electrons on them. When the spheres touch together, now the charges, or the electrons, are free to move around between both spheres. So what happens is they even themselves out naturally, and that means that half of the charges are on each sphere. And that's because these electrons all have negative charges, so they repel each other. They want to be as far away from each other as possible. So the best way to do that is to spread out evenly. If they stay like this, there's too many on this side and they're too close together. So they go like this so they can spread out as evenly as possible. So how do we answer the question? We just take the average of the two numbers here. This much charge plus this much charge divided by 2 will give us our answer. When you're plugging this into your calculator, I recommend hitting equals after you add up the two charges and then dividing by 2. You could also get around that by putting parentheses like this around the whole thing, but that can be kind of a lot to remember and just feel like a lot of work. So I do recommend just hitting equals after you add up these two numbers and then dividing by 2. And we should get negative 6 times 10 to the negative 6 coulombs, which unfortunately is not an answer choice. That's because they're not asking us for coulombs. They're asking us for the electrons on sphere A. And as a side note, if they asked for sphere B, we would do the exact same process. There's really no difference. But they're asking us for electrons, not coulombs. So we are not done with the problem yet. We still have one more step. We have to convert from coulombs to electrons. If we're starting with negative 6 times 10 to the negative 6 coulombs of charge, and I want to know how many electrons that is, I'm going to divide by the amount of charge in each electron. So I'm dividing by negative 1.6 times 10 to the negative 19 coulombs. I like to think of it as canceling out coulombs, because something divided by itself will just cross out. And I know that I'm looking for electrons, so that means I don't want coulombs, so that's something that I can just think about crossing out. Because it can be hard for us to remember, should I divide or should I multiply? So I think about dividing when I'm trying to get rid of this unit, coulombs. When you put this into your calculator, make sure you do put parentheses around this number in the bottom, because if you don't, you're going to get the wrong exponent. In a multiple choice question, that's not the end of the world usually, but on an open-ended question, it will matter, and you wouldn't get the points if you have the wrong exponent. Alright, so when you plug this into your calculator, you should get 3.75 times 10 to the 13, and that's the amount of electrons. Sometimes they'll ask for elementary charges. Think of it as the same thing. electrons and elementary charges, you would do the same process. So 3.75 times 10 to the 13, and that is one of our answer choices. We just had to round to 3.8. So you might not always have to do this second step where you convert for all of these types of problems, but anytime they say that the spheres are touched together and then separated, you're just taking the average of the two numbers, and that's how you're going to get your answer. Depending on whether they're asking you for coulombs or elementary charges, you may or may not have to do this extra step where you divide by negative 1.6 times 10 to the negative 19.